Well, welcome back. We're going to continue. And for this chapter, we're going to be talking about developing fundamental PLC wiring diagrams and ladder logic programs. So you can see how each chapter is building upon what we talked about previously. For electromagnetic control relays, relays that make logic decisions, a PLC was originally designed to replace control relays that made logic decisions. Interesting. You can see what we have here. An electrical relay is a magnetic switch which uses electromagnetism to switch the contacts. So we could either have an energized or a de-energized state with that type of a setup. And it is fairly large. You can see that. So normally open, NO, and normally closed, NC contacts are what we would have. And NO contacts are open when the coil is de-energized and closed when the coil is energized. NC contacts are closed when the coil is de-energized and open when the coil is energized. So we can see that. For the symbol, the letter M is frequently indicates a motor starter coil, and CR is used for control relay. Switch open and coil de-energized, this is what it would look like. And then a switch closed and coil energized, we would have something like that. So for contactors, contactor is a special type of relay designed to handle heavy power loads that are beyond the capability of a control relays. So thus you can see if you're dealing with a lot of power, you're going to need to have something like this. PLC used in conjunction with a contactor to switch power on and off to a pump would be an example of where this would be used. What about motor starters? The motor starter is made up of a contactor with an overload relay attached physically and electrically to it. So if you get a current spike, you want to have it trigger. Here we see a hardwire three-phase magnetic motor starter and see what that would look like. And so you can look in the textbook for more details on that. Here we have a PLC programmed with magnetic motor starter. So we have that laid out. In terms of manually operated switches, the manually operator switches are controlled by hand. So for this scenario, normally open it, makes a circuit when it is pressed and returns to its open position when the button is released. For normally closed, it opens the circuit when it is pressed and returns to the closed position when the button is released. And then break make, when the button is pressed, the top contacts open before the bottom contacts are closed. And so that can be an example of something that you want to make sure that there is no signal path as you're doing a switching, so you break before you make. A selector switch operator is rotated to open and close contacts of the attached contact block. So this is what we can see how that would work. For a dual inline package on switches or dip switches or small switches, assemblies designed for mounting on printed circuit board modules. And maybe you've had a motherboard that had these types of things. You may have actually set some of those. So the dip switches use binary on or off settings to set the parameters for a PLC module. What about for mechanically operated switches? A mechanically operated switch is controlled automatically by factors such as pressure, position, or temperature. Limit switches are designed to operate only when a predetermined limit is reached, and they are usually actuated by contact with an object such as a cam. So keep that in mind. Temperature switches, a temperature switch or thermostat is used to sense temperature change. Temperature switches open or close when a designated temperature is reached. So your HVAC at home would be an example of something like that. Pressure switches are used to control the pressure of liquids and gases. They are designed to open or close their contacts when a specific pressure is reached and can be pneumatically, that is with air, or hydraulically, that is with liquid, actuated. Level switches are used to sense liquid levels. The float switch is a type of level switch which is weighted, so as the liquid rises, the switch floats and turns upside down and actuating its internal contacts. Okay, in terms of sensors, proximity sensors detect the presence of an object without physical contact. These solid-state electronic devices are completely encapsulated. We have proximity sensors operate on different principles depending on the type of matter being detected. And inductive proximity sensors are used to detect both ferrous metals, that is containing iron, and non-ferrous metals such as copper, aluminum, and brass. Inductive proximity sensors operate with electromagnetic fields which vary in strength relative to a target. In terms of connecting a proximity sensor, the method of connecting the proximity sensors varies with the type of sensor and its application. You can have a 3-wire sensor as shown here, or a 2-wire sensor, and the ways that those could be wired up. In terms of the sensing range, proximity sensor sensing range, most proximity sensors come equipped with an LED status indicator to verify the output switch action. In terms of bleeder resistor, a small leakage current flows through the sensor even when the output is turned off. When the sensor is on, a small voltage drop is lost across its output terminals. To operate properly, a proximity sensor should be powered continuously. The bleeder resistor allows enough current for the sensor to operate, but not enough to turn on the input. Capacitive proximity sensors operate within an electrostatic field and are actuated by both conductive and non-conductive materials. When the target nears this sensing surface, it enters the electrostatic field of the electrodes and changes the capacitance of the oscillator. Capacity proximity sensors will sense metal objects as well as non-metal objects such as paper, glass, liquid, and cloth. The larger the dielectric constant of a target, the easier it is for the capacitive sensor to detect. This makes possible the detection of materials inside non-metallic containers. For magnetic reed switch, it is composed of 2 flat contact tabs that are sealed in a glass tube. When a magnetic force is generated parallel to the reed switch, the reed will be drawn together to actuate the switch. Here is a magnetic reed float switch, and so you can look in the textbook to get a little bit more information on that. For photovoltaic versus photoconductive, a photovoltaic cell and the photoconductive cells are examples of light sensors. So first you have a photovoltaic sensor, and then we have the photoconductive cell as 2 options for how we can be doing some detection. A photoelectric sensor operates by detecting a visible or invisible beam of light and responding to a change in the receiving light intensity. Photoelectric sensors are composed of a transmitter that is a light source and a receiver that is a sensor. For a through beam, the scan technique refers to the method used by the photoelectric sensor to detect an object. The through beam scan technique places the transmitter and the receiver in direct line with each other. Because the light beam travels in only one direction, through beam scanning provides long range sensing. So keep that in mind. For a retroreflective scan technique, the transmitter and receiver are housed in the same enclosure. This arrangement requires the use of a separate reflector mounted across from the sensor to return light back to the receiver. For fiber optic sensors, they use a flexible cable containing tinier fibers that channel light from the emitter to the receiver. Fiber optic sensor systems are completely immune to all forms of electrical interference. So that's a nice thing. For barcode scanners, they are the eyes of data collection system. A barcode module reads the barcode on boxes as they move along a conveyor belt. The PLC is programmed to divert the boxes to the appropriate product lines according to the barcode data. An ultrasonic sensor operates by sending high-frequency sound waves towards a target and measuring the time it takes for the pulses to bounce back. So you can have it detecting the level of chocolate. That might be something you could be doing, or detecting the transparent bottles. And so that could tell you how full a bottle is or something like that. Here we see the returning echo signal is electronically converted to a 4 to 20 milliamp output, which supplies a monitored measurement of level to external control devices. A strain gauge converts a mechanical strain into electrical signal. The force applied to the local cell causes it to bend. This bending action also distorts the physical side of the cell, which in turn changes its resistance. The thermocouple is the most widely used temperature sensor. The thermocouple operates on the principle that when two dissimilar metals are joined, a predictable DC voltage can be generated. For an RTD, or resistance temperature detector, it operates on the fact that the electrical resistance of metal is directly proportional to temperature. The hotter the RTD becomes, the higher the value of its electrical resistance. For flow measurements, flow measurement involves converting the kinetic energy that the fluid has into some other measurable form. Turbine flow meters use their rotation speed to indicate the flow velocity. For tachometers, tachometer generators convert rotational speed into an analog voltage signal that can be used for a control application. And finally, optical encoder is used to convert linear or rotary motion into a binary digital signal. The optical encoder uses a light source shining on an optical disc with lines or slots that interrupt the beam or light to an optical sensor. An electronic circuit counts the interruptions of the beam and generates the encoder's digital output pulse.